Hi, this is a brief video introducing ions. I've done a video introducing the atom, introducing the periodic table, introducing the idea of molecules. This is a video introducing ions. Well, what are ions? What is an ion? Well, an ion is an atom that has lost or gained an electron. And as you know, the neutral atom has a balance of protons in the nucleus, which are positive, and electrons, which are in a cloud around the nucleus, and the electrons are negative, and the protons are positive. Now, the neutral atom has a balance. It has the same number of protons and the same number of electrons. The number of protons tells you what atom it is. So a carbon atom has 6 protons. But the electrons that are in the cloud around the nucleus, some atoms can lose or gain an electron. And when that happens, if it loses an electron, then it's become more positive because it gave away some of its negativity. It went into therapy and it became less negative. If it gains an electron, then it becomes a negative ion. So an ion is an atom that has either lost or gained an electron or electrons such that it takes on a positive or a negative charge. Now, a positively charged ion we call a cation. And the way I try to remember that is by saying that cats are positive, which of course makes no sense whatsoever because cats are not positive in the slightest. But we can say that a cation is a positively charged ion. That means it has less electrons, less negativity, than it would if it was a neutral kind of atom. And an anion is a negatively charged ion. It has more electrons, more negativity than it has protons. And so you might think I'm negative toward onions. I don't know if that helps you. But cats are positive. That'll get you going here. Well, here's an example. So take the element sodium, which because it's so old has the symbol Na, going back to Latin. And so it doesn't look like it the way it sounds, but we'll deal with it. So sodium, whose symbol is Na, tends to lose an electron. And because it loses an electron, it becomes more positive. It loses some negativity and it becomes more positive. And so it takes on a 1+ charge. By the way, for some reason, it kind of annoys me. Charges are written with the plus or minus after the number. Anyway, I'm stuck with it. So we might say that the sodium ion is Na+, which means +1. On the other end of the spectrum of the periodic table, we have chlorine. Chlorine, with the symbol Cl, it tends to gain an electron and take on a -1 charge. And so the chlorine ion is Cl-. In general, the trend is metal atoms, which are on the left side of the periodic table, metal atoms tend to lose electrons and become more positive. They lose their negativity and they become more positive. While non-metal atoms, which tend to be on the right side of the periodic table, tend to gain electrons. And so you often have these marriages between the left side and the right side of the periodic table. Now there are also, by the way, polyatomic ions as well. These are ions that are actually little collections of atoms. So for example, NH4, 1 nitrogen and 4 hydrogens, it tends to, I didn't put the charge there, but it tends to take a +1 charge, and it's called the ammonium ion. So it tends to be a package, an ion that's a package of atoms. Sulfate, SO4, sulfur and 4 oxygens, is the sulfate ion, and it takes a -2 charge. So you can have polyatomic ions as well. Now, how can we predict what kind of an ion, or if it will be an ion? Because not all atoms really do ions. It's the ones on the edges of the periodic table that tend to do ions, especially the metals. And so how can we predict this? Well, here's a principle that you'll know thoroughly by the time you're done with chemistry, and that is that noble gases are to die for. The noble gases are at peace with the universe. Everybody wants to be a noble gas. And so if an element can either lose or gain enough electrons to look like the nearest noble gas, it will. And so group 1, which is the far left first group of the periodic table, they tend to lose an electron, because if they lose an electron, then they're back to the full shell beneath it. As we're going to find out as we go in chemistry, the electrons arrange themselves in shells and subshells. And so if a sodium, which is in group 1, or a lithium, which is in group 1, if it can lose that lone electron that it has, group 1 means it has one valence electron, one outer electron. If it can lose that electron, then it'll look like a noble gas, and it will be at peace. So group 1 tends to go positive 1. Group 2 is 2 electrons off of the nearest noble gas. So if it can get rid of its 2 electrons, like beryllium, if it can get rid of its 2 electrons, then if it can get rid of all of its outer shell electrons, 2 of them, then its next shell will be full, and it'll be like a noble gas. And so group 2 tends to go positive 2. Group 7, which is on the other end of the periodic table, all it needs to do is get 1 electron, and then it's like its nearest noble gas. And so atoms from group 7 tend to be ionic in a -1 charge. Finally, group 6 tends to go -2. These are the ones that are just 2 away from the nearest noble gas. So this is how you can kind of predict. Ions tend to be on the edges of the periodic table that either by gaining or losing electrons can become at peace with the world like the noble gases. So ions trade electrons. Elementmatch.com, this is where sodium goes to find all of its dates. And so a sodium wants to give away an electron because it's in that first group. Chlorines are in that second to last group. They want to get an electron. It's a match made in chemistry. With this electron I thee wed. And so the sodium gives its electron up, and it becomes like a noble gas. And the chlorine takes, with this electron I become a happy camper. And so chlorine becomes -1, and it becomes like its nearest noble gas. And we have bada boom, bada bing. We have a sodium chloride ionic compound. By the way, in water, this is going to completely just float around. Sodium ions floating around, chlorine ions floating around, and so forth. They completely dissociate in water. Salt, it's a salt, really. Basically, sodium chloride is salt, if I didn't tell you that. I didn't. Okay, I've told you. Sodium chloride is salt. There are other salts, by the way, which are also group 1 elements that have wed group 7 elements. So like potassium chloride is another group 1 element that likes to give up its electron and marry a halogen in group 7. Okay, so ionic compounds are generally a metal and a nonmetal that have married each other, but they don't hang around each other that much. It's a perfect marriage. I'm just kidding, because they tend to dissociate in water and float around. Okay, but if they are a solid, in their solid form, they are generally 3-dimensional lattices, rows of sodiums and chlorides. And this, this lattice can go so big that, in fact, we just use the basic empirical formula for them, like NaCl, because it doesn't make sense to say Na11Cl11, and so forth, or Na103 Cl103. Okay, writing formulas. So when we write formulas, the positives have to equal the negatives. And so NaCl is fine because Na is +1, Cl is -1. It equals out. It's great. If the charges are equal, therefore, in an ionic formula, it's very nice. It's easy. NaCl, like I said. Now, if they're not the same, then we use the crisscross rule. So, for example, aluminum is a transition metal that can take a 3+ charge or +3 charge. Oxygen, because it's in that second to last or third to last group, can take on a -2 charge, 2 negative charge. So how are we going to figure out how these can balance each other out? Well, we use the crisscross rule. The 2 on the O becomes, so the superscript on the O becomes the subscript on the aluminum, and the superscript on the aluminum becomes the subscript on the oxygen. And so there you have it. So it's crisscross. You have basically here the 3 goes down there and the 2 goes down there. See? Criss-cross. Applesauce. So that's the way it works in coming up with the formulas for ionic compounds. Well, this has been an introduction to ions. I hope you've enjoyed it.